Okay, folks, welcome. So, hope you've been doing well. Um, I'm doing fine. My family's good. I hope your family is good. I went into the school yesterday. We all went in and picked up some of the stuff that we need to try and keep this online learning going successfully. So I grabbed my smart notebook files, and so I have them all, and that's awesome because now I can go back in and create lessons and like we would normally be doing if we were in class. So here we go. Um, this one's on ratio. I've been sharing with you some video and everything else about ratio with Khan Academy and University of Waterloo's courseware site there. Um, we'll still be doing quizzes and stuff online. We'll still be doing assignments online and through the Google Classroom, but now I can also go through some lessons, which I think you might be thankful for because it's kind of what you were used to in class. By any means, if anyone's having difficulty with any of this stuff, please just email me and let me know what's happening because I don't know. It's hard I'm getting no feedback through the computer screen, obviously. So if there's something that you need to tell me, then please message me and then hopefully we can work it out. Okay, so the good thing about these are I'll be recording and you can, save it and save it and rewind back over and go back over some of the stuff that we're talking about. So if I did go too quickly while I was talking, then at least you can slow me down and figure it out before you move on to the next idea. Okay, so here we go. This one's going to be a few slides long, so this is your lesson for this is Tuesday here today, okay? So talking about ratio, we're comparing similar, same type of things. So in this case here, we're talking about hamburgers and pizza. Hamburgers and pizza are food items. So the food items are the things that are being compared, and we can write these things in a ratio, right? So a group of students had a choice of burgers or pizza. There were 12 students altogether. 5 chose pizza, 7 chose hamburgers. So we can write these things up in ratios. So we're comparing food amounts. So we talk about ratio of pizza to burgers. And if you look down at the pizza, we have 5, 7 burgers. So it's a 5 to 7 ratio. Now, one thing to keep in mind here, when we look at ratio, whenever we see ratio, look at the first word that's mentioned, right? Look at the first word that's mentioned, and that's going to be the first number. So pizza, 5. 2 is like the colon, the word 2, right, is the colon. And then hamburgers, 7. So it's a 5 to 7 ratio, pizza to burgers. But if we said it the reverse way, if we said burgers to pizza, it would be the reverse, 7 to 5. Same two numbers, just written obviously in reverse. Now we could talk about total items here, right? We could talk about total items. Total food items is 7 burgers, 5 pizzas, 12 items altogether. So 12 food items. Now this is where fractions and ratios are very similar. Fractions talk about parts of a set compared to the whole set, right? So that's a part to whole ratio. This example here, pizza to burgers or burgers to pizza, is a part to part. But I could make it a part to whole as well. Part to whole. If I said, let's talk about pizza compared to the whole group of items. Well, pizza, it's not changing. Pizza, there's 5 pieces of pizza, but the whole would be 12. So in this case, the 5 to 12, and by the way, you can write ratios like you write fractions, 5/12, and I find it easier to do that because, we're going to be dealing with equivalencies and what have you soon enough when we talk about proportion. Um, it's a nice, I don't know, representation of the ratio. But it's up to you. You can write it in a colon, you can write it as a fraction, you can write it with the word 2 in between, 5 to 12. Okay? All right, moving on. Let's talk about proportion here. So if if we said let's read. When two quantities increase or decrease at the same ratio, they're called indirect proportion. You use this when you bake, and hopefully maybe some of you guys are baking now, right? That you're home for a little bit, making cookies or cakes or whatever, and then you get a recipe that calls for a certain amount of one item, but you think, I would really want to make half that much, or I want to make a third of that much. Everything, all of your recipe ingredients have to be reduced by that same proportion. Okay, so that's what we're talking about for proportion. This one's talking about paint, right? Making a certain color, a mixture, 4 red cans and 1 white can. It's a 4-to-1 ratio. 4 red, 1 white. So that's going to make I don't know, a pinky color, I think, if we think about combining red and white. But let's say that's what we need to paint a shed. So down here I said there's 5 total tins, right? 4 plus 1 is 5. So again, we could put these into part to whole, part to part. Um, but that's what we need for painting a shed. Now let's say on the next slide we want to paint 2 sheds. What do you think? How many cans of red, how many cans of white if I'm painting 2 cans? Or sorry, 2 sheds. All right, let's look. Well, if we have to paint 2, we have to double everything, right? We have to double the amount of red, double the amount of white. They both have to double. So if I had 4 red before, 4-to-1, right? 4-to-1. It's now going to with another 4-to-1. It's now going to be what? 8-to-2, right? So sorry, I'm trying to write on a tablet here. 8-to-2, and that's proportionally increased. They both have doubled. All right, what if I want to make 4 sheds? What do you think? Tell me what 4 sheds are going to be. Let's look. If I want to make 4 sheds, I have in my initial ratio a 4-to-1, a 4-to-1 ratio of red. It's always nice to put the letters in too, so you remember what you're dealing with. Red to white, that's R to W. Now, if I want to make 4 sheds, that's 1 shed. That's equal 1 shed. Let's say that's what we have here. But if we want to have 4 sheds, how does 1 become 4, right? Everything's got to increase 4 times, right? 1 times 4 is 4. So white has to increase by 4 times, so that will be now 4. Red also needs to increase by 4 times, so that's going to be 16. So therefore we're going to have 16 red cans of paint and 4 white cans of paint. Okay, that's proportion. All right, let's look at our next note here. I wrote this up yesterday. Hopefully there's no spelling mistakes in it, but you guys bear with me. You know how sometimes I do that and make mistakes. So I've already said this before. Ratios are very much like fractions in the way that we can represent them. Okay, keeping in mind ratios can be part to part or part to whole. We've talked about that. Fractions, on the other hand, are always expressed as part to whole. All right. If we're talking about a group of pens and pencils in anybody's pencil case, let's just pick, I just made this up. Uh, let's say that there were 5 pencils and 3 pens. So that's the ratio. Is that a part to part or is that a part to whole? 5 pencils, 3 pens. Let's think. Okay. If we were to represent the writing utensils, okay, that's combining the 2 pens and pencils. We're calling them writing utensils. In a ratio of pencils to pens, that's a part to part ratio. If we were to say pencils to total writing utensils, that would be a part to whole. Okay, so writing these down, pencils to pens, remember what do we have? 5 pencils for every 3 pens. That's what will go into blanks there. Now, so that's your part to total or part to whole over here. Pencils, again, is still 5, but total is 5 plus 3. 8 total writing utensils. Okay, so now it's good we're talking proportion here. It's good to be able to to use the original proportion, or sorry, the original ratio to solve other problems. So in red here, I said, now what if we said there we had a collection of 96 writing utensils? That's a 96. How many pencils and how many pens would there be if they were in the same proportion to the original ratio, the original 5:3 ratio, pencils to pens? Now, what would I do with the 96? This is where it gets kind of tricky, or not tricky, but requiring you to think a little bit more, right? What happens to the 96? What is it? 96 represents what? Pens, pencils, or total? Okay, so which ratio should we use to calculate this? The part to part ratio or the part to whole ratio? What do we know? Well, we know, let's see, we know pencils to pens is 5:3, right? We know that part, right? Let me just check that. Yeah, pencils to pens. I just wanted to make sure I was writing this right way. What's the third number? The third number is 96. Now 96, does that represent pencils? No. Does it represent pens? No. Does it represent total? Yes, it does. It's the total. So can I use the 5:3? Well, not so much, but I can use, and I can put this into, this is called a three-part ratio. I mean, I can call this, let me see, I'll call this total, not whole necessarily. I'll call this total. So total. So I got pencils, pens, total. Now total would be what? The 5 plus the 3. So this is a three-part ratio representing pencils to pens to total. Now 96 here, that needs to go in here somewhere. I got to compare this against one of these numbers. And it has to be compared against the number that it represents. It doesn't represent pencil, so I'm not going to put it over here. It doesn't represent pen, so I'm not going to put it there. It represents total. So I'm going to put it there. And then I'm going to solve for the other two unknowns. Okay? I'm going to solve those guys. Now, there's relationships here. We always find relationships in numbers. Now, the relationship that I think you should be looking at is, how did 8 become 96? And 8 became 96. Now, you're going to have to either be pretty good with your multiples or get out your calculator. But 8 becomes 96 if we multiply by 12. Okay, that's the scale factor here. We've multiplied by 12. 8 times 12 is 96. So therefore, how do we get the other two numbers to solve our problem? We multiply them both by 12 as well. 3 times 12. What's that? Think about it. Think about it. What is it? Have a number in your head? Good. 36. And 5 times 12. Think about it. What is it? 5 times 12. 5 twelfths. I'm waiting because I know some of you got work to do on memorizing your multiples. 5 times 12, 60. Okay. So in answer to my question, if in a pencil case there were 96 total writing implements, there would be 60 pencils, 36 pens, if the ratio of pens to pencils was consistent, was proportional in the new amount. Okay? That's how we use it to solve other problems. Good so far? All right, here we go. We're almost done there. Okay. So remembering ratios can be written in a couple of ways, right? I've already talked to you about this. 3 to 5 can be written as 3 colon 5. Could be written as 3 over 5. I don't know why this guy found its way down here. I don't know, but we'll delete that anyway. Get that out of the way. Move. There we go. Good. So 3 different ways to write ratios. I like the fraction form. I think I've told you that. Writing them in fraction form can be helpful when comparing against another ratio or when trying to find out a proportional ratio, which we just did with the pencils and pens. Let's do one more example, and then I'm going to ask you to, I've already put up these practice questions. Okay, look at the bottom here for a sec. I've already put up these practice questions on the Google Classroom, the last entry that I made, which was, I think, Friday. Um, and some of you are working through the questions in the Pearson textbook that you hopefully have downloaded for free. You went to the board website, found, clicked on COVID-19 and then elementary teaching resources or whatever else. It's pretty easy to follow, but you find Pearson at Home as being something that they're offering for free right now. You got to click through, get to your grade 7, Math Makes Sense, English version, and then I think you have to create an account and register, and then you claim your book, so you have an online copy of the textbook. And now I didn't find one that I liked. Obviously, Math Power is not a book that's available because it's kind of obsolete. So I'm using Pearson. I might actually take a scan of some of the Math Power book pages and upload those. But right now, this is what we're going to work with. So the practice questions after this lesson is over are going to be Math Makes Sense. MMS stands for Math Makes Sense, page 52, 1, 2, 3, 55, 56, 1 to 5. And then I want you to hand in to the folder. I've shared with you on Google Drive a folder. You'll see someone shared a folder with you, and it's me. I want you to, now Merrick's been able to put this, has figured out this, so if you're not sure what to do, you can maybe text him. But I'm going to tell you, right click on the folder that I gave you and move it, click, when you right click on it, the window pops up, move it to your drive, my drive, okay? And then it's your name on it. That's how you're going to hand in work. And then just maybe I've seen people take actually pictures of their work that they've done on a piece of paper, loaded it in as a PDF and dropped it in there. Or I've seen people type up and create a file on their computer or whatever, and they share that with me. But one way or the other, I want you to be able to hand in work. So that you'll see your name on a folder, right click, move it to your drive, and then start putting stuff into there when I ask you for it. And then look for my conversation feedback, right? I might highlight some stuff or ask you to try something differently or give you some feedback on how you've been doing, okay? And hopefully that'll work for a bit. Okay, let's look at this last example here. So on our last quiz, the ratio of students who passed the quiz compared to the number of students who wrote the quiz was 4 to 7. That's not great, but anyway, let's say that's what we're dealing with. 4 to 7. If 28 students wrote the quiz, how many students passed and how many failed? Okay. So we have three numbers there, right? Identify the three numbers. What are they? Well, we have a 4, we have a 7, and we have a 28. Now we got to determine what each of them represent. Okay. Now, how do we determine what the 4 is? We go back in the writing, and the very first word that pertains to our numbers is going to be the 4. So the ratio, let's look here, the ratio of students who passed, there it is. That's the first number. Okay, so here I'd say passed, 4. Okay, passed the quiz. Compared, okay, there's our colon, to the number of students who wrote the quiz, 7. Okay, well this is wrote. All right. Now the next thing's 28. Okay, well 28 is going to be the third number that we try and compare here. Students, 28 students wrote. Oh, that's a wrote number. Okay, that's good to know. 28 wrote. So in our ratio over there where we have 4 students passed compared to 7 who wrote, I know 28 is a wrote number. So 28 I will need to compare with the 7. All right. So if it was only 7 students, 4 passed, but it wasn't. That was lowest terms if you think about it, right? But in a typical class, 28 is more likely the number of kids that are in the class. So 28 is the number that actually were in the class. So here we have to figure out what the 4 becomes, really. This is all we're looking at. What does the 4 become? And now hopefully you can see some relationships. Now I'm going to tell you there's a relationship between 4 and 7, which isn't as obvious because it's kind of ugly. It's, and you know, 4 doesn't really go into 7, and 7 doesn't come into 4 really nicely, but there's a definite relationship down here where you look at 7 becoming 28. That's a lot easier to see, right? How does 7 become 28? Now, again, your multiplication understanding is going to help you here if you say, oh, that's only times 4, right? 7 times 4 is 28. Therefore, what happens to the 4? It's got to be multiplied by the same scale factor. 4 times 4. 4 times 4, 16. Okay, now we're not quite done the question, but we've got some good information here, right? The question goes, if 28 students wrote the quiz, how many passed and how many failed? Okay, so you're going to say, well, I just figured out how many passed, right? Therefore, 16 passed, but what about failed? That doesn't really come into our ratio, so we got to figure that out somehow else, right? What can you do? There's a couple of ways. You can go back through a ratio if you want, right? You could go, well, uh, 3 failed for every 7, obviously. If 4 passed, 3 failed, we can do that, create a new ratio, right? Solve that times 4. Or we could say, well, if there were 28 students altogether, you might have been thinking this, just take away the 16 that we know who passed, right? And either way, we're going to get to the number what? 28 minus 16, or 3 times 4 over here if we did it the other way, times 4. It's still going to be 12, right? 12 should be the number who failed. I don't like that number who failed, but let's just say that's what the question's asking us to do. So 16 passed and 12 failed. 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 That's an E. My tablet doesn't work great. Okay, so that's ratio. That's proportion. That's finding out um, how to solve another problem based on a ratio that you're given. You got to look through the words, find the first word that you see. That's the first number in your ratio. Second word you see that relates to the numbers is the second number. You always have to keep that in order, and then you'll be fine. Okay, now one thing before I go, looking back down at the bottom, when you hand in your work, please write down the questions. Don't just write the answers. I don't have the textbook in front of me. I have to open it online as well, just like you. So write the question down as well, part of the question, so that I can follow your answers. Okay? And that's it. So awesome. That's a lengthy lesson, but that's typically what we would do in class. And hopefully you guys all followed along. The good thing is you can stop this and go back over. And now you have your recording and make your little notes and decide what you need to do to stay on top of ratio. Okay? And again, anybody have any other issues whatsoever, please just email me. Okay? I miss you guys. Take care and we'll talk to you soon. Okay? Bye-bye. Bye.